Hi everyone, this is Mrs. Lee. This is going to be on page 73. You lose some, you lose some. So I guess we're always losing some. All right, for the do now, it is going to be these three problems. If you were not here in class, make sure you do them. Or if you did not do them during class time, this would be a great time to do that. So remember, we're finding, write the ordered pair for the y-intercept of each quadratic function. So you are going to be finding the y-intercept, which means that the x, remember, is 0, because we're not going left or right of the y-intercept. And you would have gotten something that looks like this. So f of 0, plug it in, do our order of operations, right? Parentheses come first, then you multiply, and you would get it equal to 24. So you write it in ordered pair form. So it's right here like this, 0, 24. Right? We plug in the x is 0, and then our result is 24. For number 2, notice that it is in standard form. It's in standard form, we know already. But look, -5. That's the y-intercept, right? If you want to also plug it in, it's f of 0, and then if you plug it into 0, that whole thing just becomes 0 because we're just multiplying by 0, which makes everything 0. And then the 9 times 0, what's 0? That's why that's -5. That's why the y-intercept is -5. So we have that right there. Last one, this is in vertex form. Now you might want to be tempted to say, well, if that one by itself is -5 is y-intercept, then so must the 14. And you would be gravely mistaken, so don't do that. So the 14, remember, is part of the vertex, which is the highest point, not necessarily the y-intercept. Okay, so we actually have to plug in 0, just like how we did for the number 1. So 0 minus 1, that's going to be 1. That's a positive 1. And then there's my times right there because I had accidentally put in a minus, a negative. And then, so that'd be 1 squared, negative 1 squared, which is just 1. And 5 times 1, 5. Anyways, we get 19. All right, so there. Our learning goals, which is i.e. our learning targets, is just this highlighted area. We're not doing the linearly or exponentially. So we're going to compare the functions increasing either quadratically or just quadratically by analyzing the average rate of change of the function. Also, we're going to use multiple representations of quadratic functions to identify key characteristics, such as maximum, minimum, intercepts, both of them, and the axis of symmetry. All right, those should all be familiar words to you. Okay, so now the other thing, the next thing we did is the function form file cabinet. So this is going to be found on page 85 to 86. So you're flipping, go to page 85, 86. I'm going to scroll. Oh, look at all the things we're going to be doing. Oh, right here. So here, it should look like this. This is page 85. If you notice right here, this is general form. Then we have factor form here on the right, and below we have vertex form, and then we're going to graph the quadratic function. All right. Okay, so for the general form, what we do know, always the A, right? We know that it opens up. We always know that just by looking at the form, right? We're not doing any computations right now. And we also know the y-intercept without having to do any computations right there. I color coordinated that. So and the other thing that we would, oh no, we'll just go on. All right, so then from here, what we did was we just graphed it because we can't actually we don't know anything else without having to do some calculations to get the factored form or the vertex form. Next unit, we're going to talk about that. We're going to be able to do it algebraically. We won't always have to graph, okay? But a graphing is a good way to check it. So what we did was we went on Desmos. Let me get the Desmos. Okay, and that was x squared. Let's see if I can get to that page. Somewhere here. Yes, x squared plus 2x minus 3. All right, and you can notice right here, okay, so that's -3, that's 1. So those are the x-intercepts. That's your y-intercept. And that right there, my friend, is the vertex. All right. So we're going to go back. We're going to graph that just like that. So we literally so all those black points right there were the points from Desmos. The orange point right there, remember, and this line, remember the axis of symmetry is always on the vertex. So I just drew that orange line. Remember that they do reflect, the points are symmetric. So if we know the y-intercept, right, we can say it's 1 unit away from the axis of symmetry, then we know on the other side 1 unit away is going to be the other point. Okay, so this is just to help us make a more accurate graph. Alrighty, and also please note that this is, we're extending the graph and then we're putting these arrows on there. Okay. All right, so now that we have this information, then we can either go to the factored form or the vertex, but since I've already scrolled up to the factored form, we'll just do that. So we know that the roots here are -3 and 1. How do we know that? Because of these guys right here, okay? They are the x and y intercepts. So, sorry, just the x-intercept. Let me make that a different color. So we'll make that this light gray color. So I'm just gonna highlight that here, highlight that here. So that's gonna be these guys here, right? Which again is gonna be these guys here. So in the red, that's what that is. Those are those roots right there, all right? Parabola again opens up, and if you remember the f of x we took from this right here, because we're representing the exact same equation 4 different ways, right? One's with general, one with factored, one with vertex form, and the other one with just the graph graphically, all right? And so, and also the a, got to take the a from it too, because the a is going to be the same no matter where it goes. Since the a here is invisible, the a also here is invisible. There's that invisible one right in front, all right? And the two things that we do know always with factored form, parabola opens up or down, the concavity, and also the zeros, which we know as the roots or the x-intercepts, same thing. Right, moving on to the next one. Here, again, we know that the vertex right here is -4, -1, sorry, -1, -4, right? X comes first. And we're gonna write down the form. All we need to know is that, as well as the A, which we know is invisible, it's that invisible one that's in front of the X, right? So that's why there's no number there, because we know it's. All right, so it's X minus, and then the -1, right? The negative makes that minus a positive, and then -4 right there. And so what are the two things it tells us? The concavity and the vertex. Okay, those are the two things it shows us, right? And then, so if you have not already, do this by yourself right now. Do as much as you can, okay? So pause, do it. I'll wait. Actually, I would be paused. All right, so I'm assuming now that you've done it, like it's all filled out, or as much as you can, right? You can at least check these guys off, right? Because it's the same thing. So let's try this out. Again, this is in general form. I notice right here that my A, because I'm going to have to use my A for the other two forms, is 2. So I'm just going to call that out right now. The things that we do know, we know that it is going to be, it tells us to open up or open down, and it also tells us the y-intercept. Okay, so we expect on here that we should find the y-intercept at -30. So we're going to have to scale this a bit, our graph. All right, so now let's go and try and graph the thing. So we're going to go to our Desmos. I'm going to just unclick that, go to the next one, so you can just turn them on and off. And our function is going to be 2x² minus 4x minus 30. Ooh, this is going to be big. So I'm going to kind of move this out of the way. Go down. So remember, you can just click and drag, click and drag. All right, and if you notice right here, we have -30. We have 1, -32. Oh, I'm not getting any better. And then we have roots over here at -3 and 5. You guys remember all that? That's a lot. All right, so it looks like I'm gonna just go right down here. I'm gonna make these points. Let's make this black again. Okay, so I'm gonna go by 5s here. So this is gonna be -5. And here I'm gonna go by 1s, but I won't mark that yet. So this is -5. Maybe I should have marked down the -10. Come on, erase, do a thing. Okay, there we go. So this is gonna be -10, -20, -30, and that intersection right there was at -30. So that's the y-intercept. And then remember, I'm just gonna go here by 1s. Okay, so this is gonna be my 1. It just so that we gotta label it so we know like what we're doing, like what the scale is. And if you just label 1, you've labeled all of them on that axis. We're assuming that all the other blocks are gonna go by 1s. All right. Oh, and you should have said, Miss Lee, you forgot something. I'm like, oh yeah, you're right. That's a Okay, so -1 because we're on the left side. Okay, so our intercepts was at 1, 2, 3, -3, 1, 2, 3. And then on the other side, it was at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just right there. Okay, and then we need our vertex as well, which was going to be 32, 132. So 1 is here, and 32, -32 is like a little bit below that, right? So it's going to be barely below that, just like that. Do you see how it's noticeably different? Okay, not that much. So it's going to go like this. Okay, I'm just going to do my axis of symmetry just to help me draw this a little bit more accurately. So I'm going to make that orange again as well. And remember my other point, reflectional point, or like point that's reflected across the axis. And let's draw that line. So try to go through all the points, making sure that the vertex is the lowest point and it's rounded, not pointy. It should not be pointy. Seeing a lot of pointy things on the quiz. We don't want that, right? So right there, that's our vertex right here. I'm just going to label that right there because that's kind of hard to see. So just to be clear. All right. Now we have the graphs. Now we're going to go to the factored form. I think we'll kind of see that. Okay, so factored form, we're going to look at this. Remember, this is going to be f of x. I like to set it up. Our a, remember, is 2. So we're going to take the 2 because remember, this is the exact same function. So it should have the same a. If it doesn't have the same a, you did something wrong. X minus whatever the root is. All right, and I'm just calling these roots right here. We're looking at the graph. Don't get confused with the axis of symmetry. That's not 0, 0 here. So here's 0, 0 here, and this is 1, 2, 3. It's -3. And then the other 0 was over here at 5. So 5, 0. All right. So then all we're going to do now is we're just going to plug these in. So remember, this is going to be -3. And so the negative makes that minus a plus. So -3, and then this is going to be 5. That's it. And remember those two things that you need to check off? These are the two things that automatically easy to see without any calculations. All right. Going down the vertex. Well, we need the vertex, and luckily we wrote it down. 1, -32. I'm going to write down the function. F of x is equal to, remember, we're getting the a from the general form, which was 2. And then it's going to be x minus the x part of the vertex. And so it's going to be x minus 1 minus 32. That's it. Okay, and that's how you get all those different functions. Next unit, we will be talking about how to convert those things and how to change them. Why is it that this is a minus? We'll talk about that later. The more of the inner workings of them. Okay, so this is not done. We gotta go up. Okay, so we're flipping back to our previous page, and we're gonna go. Oh, yep. See, we just did 85, 86. And now we're going to just do problem number B, letter B. So basically we have these two functions, f of x, g of x, right? And what we want to know is which function has a greater value at x equals 8? Which one? We don't know. So we got to plug it in. So let's find out. Okay, so f of 8, so we're going to put in 8 for both functions. So we're going to go f of 8, also g of 8. Okay, so we're just literally just plugging in 8 anytime we see an x. So for f of x, anytime we see an x, we're pulling out that x and we're putting in an 8. Okay, substitution. Okay. So once you do that, you should no longer see any x's. If you still see x's, you did something wrong. You didn't substitute properly. All right, and then you would have gotten, remember the exponents first. Most people got to here okay. 77 was a lot of people's answers. This one right here, the one that tricked people up the most was, which one do you first? Which one do you do first? Do you multiply first or do you do exponents first? If you guys remember, somebody had said in class, PEMDAS, right? Which means exponents go first before multiplication, right? Or what we call order of operations. That's the way we do things. We're just saying we're going to do it in this order or else it's going to be chaos. We're going to have all sorts of numbers, right? Like we did in some of the, and actually I think all the classes, right? So we're going to go 8 squared first. Don't multiply that first. You're going to get something else, and that's not going to be good. So 8 squared, which is going to be 64. Then we multiply it by 2 on 28. If you want to put it all in your calculator, just make sure you're putting the parentheses in the correct places, or else it's going to mess you up. Okay. Again, for the tester or your work, you don't necessarily have to show all this work. I'm going to assume that you know how to do that, and then you can do this. Okay. If you're sometimes uncertain, or sometimes you put in the calculator wrong, I would recommend that you put that work in so that I kind of see your steps. But definitely, you always put in this. Okay, put in this step right here so I can see what you're putting in the calculator. If you get the right answer, I don't know how you got the right answer. Maybe you like the number 60. I don't know, right? So make sure you tell me, or make sure you at least show me that first step of plugging it in. All right, so if we notice when we put in 8 for X, we get 66 for G and 77 for F, right? So which one's bigger? Yeah, it's gonna be F. So that's why we put in here, F of 8 is greater than G of 8, okay? And you could do the same thing for the next one if you want to, but we're gonna move on. So if you notice right here, we did some stuff. So rate of change. If you guys remember average rate of change in Algebra 1, we really tried to emphasize this. Rate of change, same thing as slope. Same thing, okay? A lot of times people might think of slope as being like speed, right? Speed is like a rate of change, right? It's like the miles per hour, how many miles you drive in the number of hours. So miles per hour, or kilometers per minute, or feet per second, whatever it is, right? Other people have said velocity, right? That's also the same kind of concept, right? So for us, in math, we call that a slope, okay? And so if we think of slope, we think of M. M is like the variable that represents slope. I think M is for mountains, and mountains have slopes. Just saying. All right. And then so here, and a lot of guys will remember the rise over the run. That's literally all we're going to do. So we're going to take an interval. So if we were to just cut out all these parts, except for we're just looking at from 0 to 1. When we say 0 to 1, we don't say 0 to 1. We say 0 to 1, meaning we're looking at the X values, between the X values of 0 to 1. All right. So literally, I wrote the graph out here I graphed it over here on the right. I snipped it. And so from 0 to 1, what is that rate of change? So then we're going to actually have to go to the points of the graph, because we're wondering what's the rate of change on that graph, not just random 0 to 1, right? So if you look at here on the graph, 0 for the graph, if X is 0, Y is equal to -3. And if X is 1, Y is equal to 0. So that's why, so that's what that interval is. So we're going to go literally rise over run. Okay, so how many are we going to go up? We're going to go up 3. We always start at the leftmost point here. So go up 3 to the right one, 3 over 1, rise over run. And then we would just reduce that, that would just be 3. Okay, and then we're going to do the same thing for G of X, right? And for G of X, at 0, X equal to 0, it's going to be right here at -30. And then at 1, it's going to be right over here at -32. And so we're going to just do rise over run. In this case, we're not actually rising, we're like falling, I guess. So that would be -2, so it's 2 down, and then 1 to the right. All right, so that's why we had -2 and over 1, which reduces to -2, or simplifies to. All right, so if you notice here, we also try to do it algebraically, and because you can do it algebraically, you can totally, just like how we did up here, find out what the values are, right? So like which one, where does it start? So what we did was, well, we know that the intervals, remember the intervals are just the X values. We're going to start at 0. So we're going to put F of 0, plug it into the equation. We get 0 squared plus 2 times 0 minus 3. So it ultimately we get -3. Okay. And that's where we're starting at the -3 for the Y, right? And then for F of 1, right, where do we end up? Right? We're plugging 1 for, again, all the X's, and we end up getting 0, right? Do you remember 0? Right? The Y part was 0. So again, so if you want to write this as a point, you just write it like that. And this is going to be 1, 0, just like that. And all you need to do is, how we do the rise over the run, like visually, we would do that with the slope formula. So this right here is the slope formula. You thought you were done with that formula. You're not. It's everywhere. That's a U. So remember, that's the change of y. How much is the y changing over how much the x is changing, right? That's why when we're talking about changing, we are talking about differences, which means minus, all right? So again, change of y, remember the y is talking about the rise, and then that change of x, which is talking about the x. So we're literally going, well, for the y part, I guess, let me just change this because I think it would make more sense that way. Well, we'll end up with the same answer, but so if we're starting at, for the y part, we're starting at -3, right? Starting at -3, we're going to subtract, right? We're finding the difference to 0 because we want to go to 0. So how far is that? Well, that's -3 away. Well, yeah, we can still do it this way. And then for the x, right? Where are we starting at? We're starting at 0 minus the 1, right? That's where we end up. And what do we have? -1. And that's going to be same thing as +3/3. Okay. You could, again, you could have flipped it. What if you did 0 first, right? 0 minus a -3 over 1 minus 0. As long as you're flipping both of them, you can, if you flip one of them and not the other one, then your signs are going to be off. Okay. Yep, same thing. So you ended up at 0, right? And then we're taking the difference because it's where we started. That's going to be 3 over 1. Same thing. That's why your teachers always said, it doesn't matter which point is x1 and x2, right? As long as you keep them the same, you're good. All right. So now we're going to move on to the interval part. We're just going to do this graphically. We're not going to do this algebraically for now because I just want you to get the concept. So from 0 to 2, so that's the interval. So here's 0, we already have that one. And then an x is 2, what is y? Y is going to be 5. So what are we doing? We're rising 8, and then we're running 2. Okay, so it's 8 up and then 2 to the right. That's why we wrote 8 over 2 equals 4. Okay, and then if you notice over here, 0, that's still at -30. And over at 2, it's over here at -30. How much did we change? We actually didn't change. It's like if we just saw the first part, we turned around and then, and then we saw them again, there was at the exact same spot. It's like they didn't even do anything, right? So what's the rate of change? 0, right? Because how much are we going up? We're not. So it's 0 over, we're going to the right 2. So 0 over 2 equals 0. So literally, like if you were to open your eyes and, oh, they're there. You close your eyes and they're like running amok. But when you open your eyes again, they're like, oh, you're still there. It's like you never even moved, right? It's like, oh, like red light, green light, kind of like that. Okay, so that's that rate of change. And notice, depending on your interval, that rate of change is definitely going to change, right? But remember, if it was linear, no matter what the interval was or how big the interval was or is, it's not going to change. If that slope is 2, it's always going to be 2, no matter what segment you take. But for a parabola, since it's curvy, it's gonna change. Like the interval is gonna change. All right. So if you guys have not already done this part, try it. Okay, pause it and then do it, and see what you get. Did you pause it? Did you do it? All right. Okay, here we go. I'm assuming you've done it now. Good job. All right. So now from 0 to 3. So we already have the 0 point right here, right? So there's our 0 point. And when x is 3, it's going to be, let me look a little closer, right here at 12 it looks like, right? We'll just, if it's not, we'll just pretend that it is. So we're going to go, how much are we rising? And it looks like it's going to be, that's 12 right here, 13, 14, 15. So we're rising 15. And how much are we running? We're running 3. So we end up getting, so that slope is 5. If you notice that the slope, 3, 4, 5, it's like increasing. So it's getting more and more and more steep, okay? So, which makes sense because as you go up, because it's going to just keep on getting higher and higher, right? So it does make sense that it's going to be getting more and more steep. It makes me wonder if it will go from 0 to 4, will it be 6? I feel like it would be. And if you thought that way too, then you have your math brain on. All right, so 0 to 3 on the other one. So here's 0 and then 3. Yes, we're definitely not going to get 0 here because we're definitely going up. All right, so what do we get here? We would get 5, 6, rise 6, and then run 2. So 6 over 2, that, my friend, is a 6. And so we have a slope of 3. Which one is more steep? Which one is more steep? It would definitely be the f of x here instead of the g of x. And if you were to draw that line, you would see that it's more steep. Like this one right here, draw that line, looks like this. This one, oh, it's not bad, more steep. Okay, blue line here on the left is steeper than the one on the right. That's why the number is higher. So now we're gonna go, we're not gonna be able to find out 0, 4, so unless you guys wanna do it, then tell me. All right, so we're gonna do our last point interval right here. Let's make this purple. So we have 4 to 5, so between 4 to 5. So here's 5 right here. Oh, don't get confused with this. This is not actually, oh, actually this is the x. I was gonna say, don't be confused because sometimes they put the numbers down here. But here we go, 4 to 5, so between this, from here to here, that's the only part we're gonna look at. We're not looking at anywhere else. So here's 4, that's gonna be right here. That looks like 21, right? I think so. And then this one is gonna look like that one right there. So that's gonna be from 21 to 32, it looks like, right? So what's my slope right there? So I'm gonna rise, that's gonna be 4, 9, 10, 11. Rise 11, run 1. So 11 over 1, which is gonna be 11. And then for this one right here, here's my 4, my contacts. All right. Looks like I'm gonna go right there. That's the point. And then 5 is like right. Yep, that looks like the point. So what is that gonna be? So let's see let's see who wins. Okay, because so far it looks like that F wins over G, but we don't know about this one. This better be more steep, I don't know. So this is gonna be 4, actually this is 5, 10, 14. So up 14 and then to the right one. Ooh, 14 over 1, which is gonna be 14. G wins, right? It looks like it's getting more steep so G is getting more steep as you go, way faster. Okay, so there we go. That's how you do that. Again, this is more like a precursor to like a little preview of kind of one of the concepts of calculus, okay? Because they do talk about rates of change at a single point. And how do you find a point, the slope of a curve, right? At a single point. So they talk about tangent lines and all that. You guys will get into that when you get into calculus, no worries. All right, so we're gonna move on to this next page, 4.3, okay? And we were just looking at the graph and the, what is it called? And the tables. And we were trying to eliminate which ones they were. So if you look right here, this is in vertex form. So that's what we pulled out the vertex from that 360. And then we graphed it right here, very, very rough graph. Hopefully your graph looks better than mine. But we know it's gonna be open down because of this -5. Do you see this sad face right here? That's what that was for. And then, so we know it goes down. So we're thinking, okay, we know for sure that the y-intercept is less than 60. Where? I don't know, just somewhere less than 60. And we were probably thinking we're probably gonna have a root over here on the positive side, one on the negative side. I don't know where, right? I just know it's probably gonna, it's because the shape generally looks like this, right? So what one can we eliminate? So one person has said, well, it's definitely not 0, 60 because you know, it's already 360. We can't have 2 maximums, right? Because we already know 360 is already the maximum. 60 is already the maximum. We can't have 2 of them or else we don't have a parabola. So, yep. And because of those reasons, we call them out. Can't be that. All right. And then for this one right here, this one was a little bit difficult. Before we get to this one, we'll talk about D. Okay. So if you notice with D, I don't know if you can see, but in your book, you can see, oh, see, 0. All right, so it's 3, 0, right? And if we know at 3, what is y supposed to be? It's supposed to be 60. That's not 60. So therefore, this is definitely not it because of that guy right there. All right. And then the third one right here, we had said it was not this one because if we notice, we do know it has to be 360. And so the 3 should be somewhere in between here. And if you look at the numbers right here in between here, it doesn't look like it's going to be at 60 anytime soon, because it looks like 45, 20. It's like getting smaller, right? So if it's getting smaller, there's no way it's going to reach 60. So it looks like it's big, and then it's getting smaller and smaller, and then it's getting big again, right? So it's doing like this happy face, right? Which means that it's a minimum, not a maximum. And here we know that this is definitely a maximum. Okay, that's what can be B. Now, what made us think about C? And some people were like, kind of like, radicals. What are radicals in here? Which are square roots, right? Another word for square root. Oh, radical is just this terminology, right? But we could have square roots, we have cube roots, we can have fourth roots, all sorts of roots, right? So if you notice right here, the ones that circled, we're like, oh, 360, 360. That kind of reminds me of the Xbox 360, but I don't think that's where they got it from, right? And then we're like, okay. And then if you notice right here, 0, 15. Yeah, I'm like, well, it's positive. It could be 15, right? I didn't draw that right, but yeah, it could totally be 15. And then the roots, we're saying one of them is at negative, one of them is going to be positive. So yeah, that looks like it's it. And plus, you know, if we got 360 and all the other ones don't have that, and they're even close to that, then we're good. So, and that's why you pick C. Now we're talking about Ben and Corin. So flip the page, Ben and Corin. Okay, so now if we look at this guy, we notice they have drones, 2 drones. Well, 1 drone each, right? And so they're flying their drones, and they start at different heights. And Corin is very studious apparently, and she's like done this like whole equation thing going on, like what this can look like. Okay, and Ben's drone, he made a table, so he had a timer, and he was like trying to, I don't know how he measured it. Oh, the drone probably could calculate all that. All right, so here we go. The first question is, which flight began at a higher elevation, right? Which one started higher, okay? And that would be basically in talking about your y-intercept, okay? At time 0, x equal to 0, right? At time 0, where did the drone start? How high was it off the ground, right? And if we look over here, well, we know that one pretty easy, right? Because remember we talked about that one, it's just that +1. So we know that for Corin's drone, 1 foot above the ground. Not very high. I don't know if I can make this big. It's about this size, this depending on how tall you are, but it's about this much. And then for Ben's drone, we look over here and we're like, oh, that's why this was circled. Somebody had mentioned, oh, well, it's when if it's when x is equal to 0, starts at 4, right? So for Ben's height starts at 4 feet off the ground. Okay, so who wins? Ben wins. So Ben began at a higher, that's supposed to say elevation. I ran out of time. So higher elevation, right? Not elevation. I did that today too. Elevation, right? Starts out at 4 feet. Corin only at 1 foot. All right, so, and then it asks, what drone began descending first, like going lower? And that's why I drew this picture over here. So remember, it ascends and then descends. How do we know it makes that change, right? Remember the interval of increase and interval of decrease. What separates that? The axis of symmetry. After the fence, something happens. You cross that fence, you're never safe. Don't cross the fence. All right. So you're going up, and then once that axis of symmetry hits, now you're going down, okay? So that's what we need to find out. What is the axis of symmetry? So for Corin, we already know the formula for that, x equal to negative b over 2a. And so we're gonna plug it in. We know that b right here is, b is equal to 7. A is equal to -3. And we're just gonna plug those in. So negative, that has nothing to do with the b. So negative, and then we have b, which is 7. And then 2, which is always gonna be 2, times, what is a? -3. And then when you do all that math, you get 1.1, not 1.1 and 1/6. If you want to change it to a decimal, you totally can. But I'm just gonna leave it at 1 and 1/6. So it's a little over a second, that's when it starts descending. All right, what about for Ben? If you notice right here, you're gonna have to look at the table because we can't do an AOS because you don't have the standard form. So what we're gonna do here is we're going to look at the patterns. So we notice it goes from 4 to 4.25, then back to 4 again, which means, right, 4 to 4.25. So the 4.25 must be the vertex, right? Because if you notice also on the X, we got 0 and 0.5. What's halfway in between that? That's gonna be 2.25. 0.25, right? So this is definitely our AOS. That's our vertex right here. Vertex. My contacts are getting too dry. Okay, so that's our vertex, which means that's where our AOS is. So our AOS for Ben is going to be at 0.25. So x equals 0.25. For Corin is going to be a little over a second, right? So which drone began descending first, right? Who did it faster? They're going up. Oh, it's definitely Ben. If you said Corin, sorry. A little over 1 second is not faster than 0.25 of a second. That's like a quarter of a second. That's very fast. It's like it went up and then went right back down. I guess that's why Ben had to start at a higher place. He knew that. So Ben's drone. Descended first. All right, and then the last one here for this question, not the last thing of the whole thing. Which of the drones has a greater average increase in height over time, up to its maximum height? So from the time it started to the maximum height, what's that going to be? Well, we already know the time that it started, right? That is going to be, we're going to have to use the slope formula. It's going to just have to be. So this is the slope for MC. So slope for Corin. So what is it? Okay, where do we end up? Because we started with where did we end up? We ended up at this 1.16, right? Well, what's the y part? What's the maximum? We're gonna have to actually plug it in. All right, so we're gonna go f of. I'm gonna go back to our improper fraction because that makes life a little bit easier. I'm gonna go -3 times 7/6, and you're like, Miss Lee, really, do we have to do this? It's good to practice fractions, guys. You know, if you like music, you all like fractions. Then you know what I mean. Eighth notes, quarter notes, whole notes. What are all those things? Fractions. All right, and then +1. If you don't like fractions, don't listen to music. All right, and so we're gonna get, if you want to put that in your calculator, figure out a thing, and you're going to get something. 5.08. Okay, 5.08. So try that in your calculators. Remember, if you don't have a fraction bar, remember you just put divide, but you have to put the parentheses around that. If you don't put the parentheses around that, sad days. Okay, so it's 5.08. So we're gonna do our y is gonna be 5.08 minus what was the y that we started with? Remember, she originally was at the 1 foot, so it's gonna be -1. And then what was the time that we stopped at the highest point? That was gonna be this right here. Let me figure out what that is. 7 divided by 6, which is 1.17. It's actually 1.166666666, but I'm gonna just round that because we don't need to round. Oh, we don't need to write all that down. 1.17 minus, well, what was the original time? That was at time 0, right? So there we go, time 0. And what do we get? 4.08 over 1.17, which you get 3.49. So about 3.5. So 3.5 feet per second, you can say. All right, because remember it's always like over 1. So 3.5 feet per second. About. I should say feet per second. And then for Ben, what do we do with Ben? Ben's is a little bit easier, right? Remember we have the starting points and we also have the vertex, right? So we're gonna go, the slope for Ben, for Benny boy, is going to be, where do we end up? At the y, 4.25. Where did we start? At 4. I'm getting these numbers right here, if you did not know. And now we're looking at the x's. Well, he started descending at 0.25, right? And then minus, and we started at 0. So what do we end up getting? 0.25 over 0.25. Well, what's 0.25 over 0.25? don't need a calculator. Just how many times does 0.25 go into 0.25? One time. Slope is 1. So for Ben's drone, is averaging about 1 foot per second. So who's faster? Who has a greater average of increase? Yep, it's going to be Corinne. Corinne. You're going to have to figure that one out. Corinne's drone has a faster or greater average increase in height over time. Okay, and honestly, I could have just said greater average speed. Oh well. All right, so here we go. If you guys have not tried these, try these out. Pause, take a brain break. Okay, all right. This is talk to talk. What interval has a greater average rate of change for the interval 2, 4, right? So we're looking between 2 and 4, all right? So you would literally just plug those in right here. So f of 2 I'm going to just write down the work over here. So f of 2 is going to be 2 plus 1 squared plus 20. Right, so this would be 3. So this would be 29, right? Because 3 squared is 9 plus 20, 29. Right, so I'm going to just write 29 over here. And then f of 4. So f of 4 is going to be same thing, 4 plus 1 squared plus 20. So this is going to be 5 squared plus 20. So that's going to be 25 plus 20 is going to be 45. Okay, so I'm going to find the rate of change, which is going to be, again, 45 minus 29 over, and what's it going to be between 2 to 4, right? So how big is that? 2, or what we would say is 4 minus 2. So this would be 45 minus 29, 16? I want to say 16. I have nobody else to check me, so I'm going to borrow my calculator really quick. So that's going to be 16 over 2, which is going to be 8. Okay, so this A speed is 8. What about the B speed, right? So we're going to look between, it says between 2 and 4 right here, right? So we end up here at 4, and so from 4 to, how do we get from, I'm going to just do this. 4 minus 0? 4. 4 minus 2 is 2. So this is literally going to be 4 divided by 2, okay? Which is 2. Okay, so which one has a greater speed? The A has 8, B has 2, so it's got to be A. A wins. All right. Which function has a greater absolute minimum? Well, this one's easy one, because you get to see. That's as low as it can go. This one is negative 20. Min at negative 20. What about this minimum? Ooh. We know that this is 0 and 0. So we know that the minimum is somewhere going to be in between here, right? Is 4, 0. I don't know. Is it going to reach negative 20? Doesn't look like it, right? Because if you look at the difference between here and here, so 4 and 0 is not a lot. We're not jumping 20s. It's not like 400 or 40 or anything like that. So yeah, it's not going to get any lower than that. So it does have to be A. Okay. Okay, I guess, I mean, if you really want to find out. Okay, we know the roots, right? If we know the roots, then what? Let's try it. We've done this before. So we know the roots. It's going to be, okay, we don't know A, but we know x minus 1, x minus 4. Okay, and then how do we find A again? Oh, wait, we have another point, right? This one right here. Another point. So let's plug that into here to figure out what A is, right? So Y is 4. And then A is A, because we don't know. And then we know that X is 0. Oh, good, it's 0. Makes life easy. Okay, and then what do we get? A times, this is -1, this is -4. So -1 times -4. So 4 is equal to -4. Well, -1 times -4 is 4A. Well, what does A have to be so that it'll equal 4? So 4 times what will equal 4? And if you say 0, you would be wrong. Just be 1, right? Or you can just go divide by 4 on both sides, Miss Lee. Okay, so A is 1. So that means, what does that mean? That means our function would be y is equal to just x minus 1, x minus 4. Okay, you said you wanted to know why, like what the number was exactly. This is what we're doing. All right. Where's the AOS? I don't know. Okay, you know. All right, remember the AOS is going to be right in between those two numbers. It's like the halfway between point. So x equal to 1 plus 4. Those are our roots, remember? Divided by 2. So that's going to be 4, 5, divided by 2. Okay, 2.5. So how do we find out what the y would be at 2.5? Let's plug it in, right? So y would be 2.5 minus 1 times 2.5 minus 4, right? Like 1.5 times negative 1.5. So y would actually equal negative 2.25. That's the minimum. I told you it was going to be smaller, but that's how you would know for sure, like positively. Okay. Just so that you know, the vertex was going to be, so the vertex we found was going to be 2.5, just to tie it all up together. Vertex. Last one, right here. All right, so the last one we have, which function has the axis of symmetry has a greater x value? Well, what's the axis of symmetry here? Well, it's in standard form. Standard form is negative b over 2a. Well, what's b? There's no x. Then what is it? Remember, b is equal to 0 then, right? Because that's the only way the x would have disappeared if it was multiplied by 0. It makes things disappear. So x is just going to be negative 0 over 2 times a. A is 2. 0. So unless this b is a negative, it looks like b is winning. But we'll find out. Okay, so if we take a look here, we're going -3, 0, 0, and then 5, 30. Okay, -3, 30, 0, 0, and 5, 30. What's in between? So we know that these two are symmetrical from -3 to 5, right? Those are symmetrical for sure, which means we could find the AOS. So we're going to take a look at this guy right here. Just like how we did for factored form, how you get the roots, you could do that with any 2 points. Do you remember that from like a couple lessons ago? So we're going to go, so the AOS is literally going to be -3 plus 5, divide that by 2. What was -3 plus 5? 2, divided by 2. Just go 1. Don't say that, don't circle that, that's not your answer. That's your answer. I didn't do it for this one. You didn't see that. All right, which one's bigger? I told you, B. All right, that's it. Have a good day. Remember, our test is coming up on Monday, so don't forget. Okay, we'll have our lesson, our review tomorrow.